Lekan.
Yeah, thanks, Fer. So today I'll be presenting the funded project called MOREC, which is a Modular Relaxed Eddy Covariance sensor for air quality. So this is a collaboration between myself, Thomas Ball, Zaire, and our mentor is Rob Kennesley. Next slide, please. So this is just a slide summarizing the aim of our project. So I think the initial thing is to develop this proof of concept of using this relaxed eddy covariance, but actually leveraging on low-cost sensor technology to actually make the module very cheap. And the second aspect of our aim is actually to also try and model an ammonia sensor. And this is going to be work that we'll be doing with the STFC facility using RAW space. So the objectives are summarized there. So the first end that we're trying to deliver is the design and the demonstration of this prototype unit. So we are also going to conduct a feasibility studies, like I said, for a high resolution ammonia sensor. And finally, we would also try to explore opportunities for additional funding beyond this. So on the bottom left there, you've got the schematics of the module that we're trying to design. And we've made this modular because so that we can actually make this very versatile. So you've got the wind module, which in this first case for doing relaxed eddy covariance would be a 2D sonic measuring the vertical and downward wind. And we would incorporate that to the sample switching model, which has to be fast. And the key thing is the last aspect there, which is the low-cost sensor module, because we're trying to take the technology that we have in the industry, in this case for low-cost sensors like for gases and PM, but also with the option, like I said, once we model the ammonia, to incorporate that into it to make this a very versatile device. Next slide, sir. So we've got.
Sorry, my fault.
So what are the impact of our project? So we're trying to, first of all, create a system to allow us to do emission flux methodology, and this would hopefully help us improve our understanding and quantification of fluxes, especially if we can actually include ammonia there, because that's really key for the farming and agricultural industry because of the large uncertainty in the ammonia flux. So the second bit is, again, like I said, trying to model an ammonia sensor, and the main aim here is to improve our evaluation of UK emission inventory, because this would hopefully, by doing this proof of concept study, we come up with a technique that allows us to have a portable unit that we can actually take around different environment and try to create, at least improve the inventory that would actually help us reduce some of the uncertainty when it comes to the errors associated with emission inventory. And as you've heard in the first part of this talk by Sarah, we are trying to leverage on some of the facilities available in this network. So we are using the STFC and particularly trying to collaborate with RAW to develop this medium low cost ammonia sensor. And in addition to that, we'd also be partnering with other members of this the network to try and conduct some field trials. And once we've actually designed our module. Next slide, please. So in terms of updates, I suppose this is also something that will affect most of the projects. So we are still waiting on finalizing our contract, but in the background, we've already started doing some work with the lab aspect. So what I have here is just so what's not great, I mean, the grayed out bit is the bit we're still working on. So we've started trialing a 2D sonic, which is what you have, the image you have on the left there, and also trying to trial the fast switch board. We've already started getting data from that. So once we sort out the funding, we'll be able to then start looking at least in the aspect of using the local sensor, trying to integrate sensors into the package itself and come up with some data to evaluate the unit itself. So the next slide, please. But in terms of modeling the ammonia optical sensor, so like I said, we're already trying to leverage on the work that's already been done in RAW. And here, this is just the modeling would focus on trying to work out the interference for these species that we're interested in ammonia, and looking at the aspect of broadening mechanism, the instrument sensitivity, information on density and laser availability. And all these would, this modeling scoping study will give us an idea of the size of the package and also the portability of the instrument itself. And what I need to also mention here is that this technique is actually using new advances in mid-infrared sensing technique, and also the advances in technologies around that field. So all these brought together would actually make potentially this ammonia sensor more portable, very well, affordable and portable. So in terms of the update on this aspect of the modeling, there's already ongoing modeling work that's been done on ozone sensing. So the platform and the base is set. So once we just switch this over, the work that's been done for the ozone to try and now simulate for ammonia. Next slide, please. So for next step, like I said, we've tried to try out some part of the modular structure itself. Would extend this design up to the sensor itself, incorporate sensor into our design, and try and come up with some data to try and make sure this module, we're comfortable with that. Then hopefully we'll be able to start doing the modeling for the ammonia sensor itself. Then finally we'll try and conduct, time permitting, some field trials using the completed low-cost kit, with the hope that in the future we can actually build the ammonia sensor and put that in place, because that's really key for some of the applications that we want to do so far. And that's it from us. Thank you.
Great, thank you.